cathode and anode. It is called the cell electromotive force, that is EMF, of the cell when no current is drawn through the cell. Okay, now we'll see about what is the key features of the cathode and anode. So cathode is denoted by positive sign since electrons are consumed over here. This is in the case of the galvanic cell. It's denoted by anode, denoted by negative sign since electrons are liberated here. A reaction occurs in the cathode of an electrochemical cell. An oxidation reaction occurs in the anode of an electrochemical cell. So if it is a cathode or anode, whether it is a negative charge, despite of the charges in anode, only oxidation will take place, and in cathode, the reduction reaction will take place. Then in the case of cathode, electrons move into the cathode, and in anode, electrons move out of anode. General convention dictates that the cathode must be represented on the right hand side, whereas an anode is represented on the left hand side while denoting an electrochemical cell. So this is a representation of the cell reactions of the electrode potential. You have to represent always the anode will be at the left and the cathode will be at the right hand side. Half cells and cell potential. So electrochemical cells are made up of two half cells or redox couple, each consisting of an electrode which is dipped in an electrolyte. The same electrolyte can be used for both half cells. These half cells are connected by a salt bridge which provides the platform for ionic contact between them without allowing them to mix with each other. Okay, so that is the main purpose of the salt bridge. And they are connected in series parallel combination of the two. They are considered the wasteful and environmental harmless device. This is because they require about 50 times the energy they contain in their manufacturing process. They also contain many toxic metals and are considered to be hazardous waste. So next is the types. So there are different types of electrochemical cells. One is the primary types of electrochemical cells, galvanic, also known as voltaic, electrolytic. So the key difference between the galvanic and the electrolytics are tabulated. Galvanic or voltaic cell, chemical energy is transformed into electrical energy in these electrochemical cells, and electrolytic cells, electrical energy is transformed into chemical energy in these cells. Galvanic cell, the redox reaction that takes place in these cells is spontaneous in nature, and in the electrolytic cell, an input of energy is required for the redox reaction to proceed in these cells. That is, the reaction are not spontaneous. So what is spontaneous? The reaction will take place by itself. Non-spontaneous means it should be initiated. The reaction should be initiated to take place. In these electrochemical cells, the anode is negatively charged and the cathode is positively charged. And in the electrolytic cells, features a positively charged anode and a negatively charged cathode. Galvanic cells, the electrons originate from the species that undergo oxidation. Electrons in electrolytic cells, the electrons originate from an external source such as battery. So there are many applications of the electrochemical cells. Electrolytic cells are used in the electro-refining of many non-ferrous metals, in comparing relative reducing or oxidizing power of elements, in predicting the feasibility or spontaneity of a redox reaction. The production of high purity lead, zinc, aluminum and copper involves the use of electrolytic cell. So this is an important application of the use of the electrolytic cell to give a pure product, pure elements like metals like lead, zinc, aluminum and copper, and predicting whether a metal can evolve oxygen from an acid or not. Many commercially important batteries such as the lead acid battery are made up of galvanic cells. Comparison of the reactivities of metal and non-metals. Determination of Gibbs energy change. Determination of equilibrium constant. So these are the few of the main applications. So we can set up a simple voltaic cells and measure its EMF. Okay, so the aim, what is the aim? It is to set up a simple voltaic cell Materials you required is a beaker, 250 ml, porous pot, connecting wires, voltmeter, zinc strip, sandpaper, copper strip, 1 mole of zinc sulfate solution as well as 1 mole of copper sulfate solution. Okay, so we are having the concentration, different concentrations. Okay, zinc sulfate solution you are taking in the different concentration is everything, 3 cases 1 molar, but the copper sulfate you're taking 1 molar, 0.1 and 0.01. So voltmeter reading will range from 1.1 volt, 1.07 volt, 1.04 volt. Okay, so these are the readings that is obtained. So when we infer the result, what will happen? The EMF of the assembled cell is X volts. The EMF decreases after passage of time. The EMF of the cell change with the change in the concentration of electrolytes. So next is the reading in the change in the concentration. For 0, 1.1, 5, 1.1, 10, 1.09, 15, 1.07, 20, 1.05, 25, 1.03, 31. So that's all in this. We will see about next about the standard hydrogen electron and calomel electrode in the next session. So one more topic is left, that is the electrochemical cell and the electrolytic cell, the difference. So electrical energy is created by converting chemical energy in the electrochemical cell. Electrolytic cell, chemical energy is created from electrical energy. A redox process produces electrical energy in electrochemical cell. Electrolytic cell using electricity causes a redox reaction. Electrochemical cell, the cathode is positive while the anode is negative. Electrolytic, the cathode is negative while the anode is positive. In electrochemical, reactions of oxidation and reduction are carried out independently. Electrolytic, in the same container, a redox reaction occurs. Electrochemical, electrons go through an external circuit from the cathode to anode. Electrolytic, electrons go through an external circuit from the anode to cathode. And in electrochemical, a salt bridge is required. Electrolytic cell, a salt bridge is not required. Just winding off this topic. Thank you.